So this is the third example, which is the application of binomial distribution. The probability of a telesales representative of a Koei company making a sale on a customer call is 0.15. Find the probability that no sales are made in 10 calls, and B, more than 3 sales are made in 20 calls. So let X be the number of sales made. First, identify the total trials, which is made in 10 calls. Therefore, the N is 10. Next is the probability of success. Getting sales is 0.215. So P is 0.15. Therefore, X is binomial distributed with 10 and 0.15. By using the formula NCX p power of x1 minus p power of n minus x. Okay, let's solve the first question, which is no sales are made in 10 calls. Therefore, here, your x will equal to 0. So substitute the number of trials 0 and the number of sales is 0. P is 0.15. Then you can get 0.161969. The second question is, find the probability that more than 3 sales are made in 20 calls. So here, the number of trial is 20. So N is equal to 20. However, the probability of making a sale is the same, which is 0.15. Therefore, X is binomial distributed with 20, 0.15. So by using the same formula, now your X is more than 3. Therefore, X is greater than 3. It is equal to 1 minus P, X less or equal to 3. It means that you need to the total number of probability of getting sales is 1. And then P, X less equal to 3. It means that you need to find the probability of the number of sales 0, 1, 2, up to 3. Therefore, 1 minus the probability of getting sales 0, 1, 2, and 3, then you can get the probability of making sales more than 3 is 0.3523. Next, the question is continued to the second part. Representatives are required to achieve a mean of at least 5 sales each day. Therefore, find the least number of calls each day a representative should make to achieve this requirement. So here, let X be the number of sales made and identify what is the number of trials. Since the question want you to find the least number of calls, it means that you need to find the n number of trials. And then the probability of making sales still the same, which is 0.15. So X distributed with binomial n 0.15. So we know that the mean of binomial is n multiplied with p. Here, the question has stated that the representatives are required to achieve a mean at least 5 sales. Therefore, mean at least greater or equal than 5. We know that P is 0.15, so you just substitute, and by using the algebraic, 5 over 0.15, therefore, the n you will get 33.33. However, this is the number, so it is approximate to 34. Therefore, the least numbers of calls each day to be made by the representative is 34. The last question, calculate the least number of calls that need to be made by a representative for the probability of at least one cell to exceed 0.95. Let X be the number of cells made. The N, still, you need to find the least number of calls that need to be made. And then the probability of getting cells is 0.15. So here X is binomial distributed with N 0.15. Now, the question asks you the probability at least one cell to exceed 0.15. So means that the probability of getting at least X is greater or equal to 1. Cell to exceed, so must be greater than 0.15. Okay. Probability of X greater or equal to 1, it means that 1 minus the probability of no cells to be made. So, 1 here, you transfer to the right hand side, you will get Px equal to 0 less than 0.05. This is because 1 minus 0.95 is equal to 0.05. So substitute the formula of binomial and Cx 0.15 power of x 1 minus 0.15 power of n. Then here you will get 0.85 power of n less than 0.05. So by using your mathematical knowledge, taking on both sides, you will get ln 0.85 power of n less than ln 0.05. Then bring n to the front, you will get n ln 0.85 less than ln 0.05. So for n, you will get n greater than ln 0.05 over ln 0.85. Therefore, the value of n is 18.433. Remember, in statistics, we will round off to the nearest with +1. So since n greater than 18.433, so the number is approximate greater. So n is equal to 19.